Hello everyone, welcome back to the workshop. And as we are rapidly approaching the holidays and the shopping time that comes around with that, seems like everybody's kind of pushing out their new products, and Atomstack is no different. They have a new laser series on the market called their A6 series, and they sent one out to us to take a look at. We're going to be diving into this one. It has a kind of a one-piece unibody frame, a little smaller working area, but it has a lot of the features that I know myself have been looking for in lasers, as well as hopefully a few surprises. So if you're curious about what this laser has to offer, stay tuned. We're going to jump right into it. All right, well, here it is. This is the Atomstack A24 Pro, and this is part of their A6 series of new lasers. They're calling it a second generation laser and such. And so we're going to take a look at it, but as it comes out of the box, it is mostly assembled, and I will put up a few clips of unboxing this and the basics assembly. Now on their website and some of the advertising, they post this as a no assembly unit. However, there are a few things you need to do. Now the frame is all together, most of the wiring is there, but you do have to attach the mounting plate to the gantry, as well as then slide on your laser module, and then there are some your air hose and your module wire to the side block that do need to be connected, and some cable management clips put in place. So it's not 100% no assembly. There are just a few screws to put in for that mounting plate, and then the rest is fairly plug and play. But it is very simple. I mean, it's mostly built. This frame is literally one piece. There are no joints, there are no screws holding this together. This is one piece for the most part. So it is going to be a fairly rigid frame, and should be square because there's nothing that you can adjust there. So this laser is a little bit smaller than your typical diode laser. It is 365 by 305 millimeter working area. So your 365 is your side to side, your X gantry, and then your 305 is forward and back, your Y axis. So it has a smaller working area than typical diodes. That's a decent working size. You're going to still have a good 12 inches square plus to work with in that. And a lot of the projects I'm working with are not a whole lot bigger than that. So yes, it's a limitation, but for the average person getting started, this is also going to mean it's going to fit into smaller spaces. They do have some excellent cable chain here, and that helps with the management. And then they have some semi-rigid, but then they're clipped in place wires management on the X gantry, so that it kind of stays up and out of the way, and that's going to really prevent it from dragging across the material. They also have put your air assist inlet on the back right corner, so that's kind of out of the way. Your cables for managing the device are on the right side front corner, so they are out of the way. They do have some extra things on the front panel, but they're down here. That leaves this whole frame up top kind of open and unobstructed. So there are actually some additional accessories that we will talk a little bit about at the end of this video, but that is to help keep some of these things out of the way, because there are some things that might mount in there later. Some of the safety features of this laser are that they have a keyed system, so you can lock your laser out or you can turn it on. My only complaint about this is that when it's on, you have to leave the key in there, which I understand you don't want to lose that, but it then kind of gets in the way of certain enclosures and such. So I'd love to be able to have this lock on or off, and then be able to get that key out of the way. It does have tilt detection as well, so there's some gyroscopes in here that if it does get bumped, it should kill the laser. And they do have an emergency switch. Now, it's not an e-stop button, it's a rocker switch on the front panel. Great to see it there. I'm not sure how easy that's going to be to possibly get bumped, or whether it's going to be that thing you can just kind of slam down in emergency, but it is there and able to be used. So a few other features they talk about with this laser. It does have a red crosshair positioning system, so we've seen this on a few other lasers. It is offset just a little bit from the laser head, and so you can use that for framing. This is a great option, however, if you're using kind of the maximum working area of your laser, and that has to be offset from your actual laser output, you can run into situations where it can't frame that because of the object's size. So that's where it kind of falls short a few times. And you also do have to make sure that that offset is calibrated within Lightburn. It's usually not a big deal. There's a certain XY offset you can assign to it and you can tweak that, but it does add just a little bit of variability to using just the actual laser spot for framing. It does include limit switches, which is great. This allows you to have a home point as well as soft limits, and then you can then definitely do repeated cuts based off of absolute coordinates. And so I prefer having them in there and being able to work with absolute coordinates. It's not a deal breaker. I've seen a few lasers come out recently that don't have them, and so you're just working off current position, but great to see that on there as well. Now they do specify that this has a spot, a highly compressed spot size of 0.06 by 0.06 millimeter, which in a 24 watt laser or 20 to 24 watt laser, that's huge if that's true, because that should condense more of that power into a smaller area, thus allowing us to hopefully cut deeper and also faster. So it'll be interesting to see how well that performs, and if that's true. It's going to be hard to exactly measure it, but we can kind of take a look at things like kerf to see if it is truly square, and see in their performance of our cuts to see if it's performing better. So definitely excited to see that. That's part of their second generation style of laser head that they're touting on this. And if it's true, it's going to be nice to see this in this laser as well as future ones as well. Now, they do have air assist control through Lightburn via the output port on the side of this laser. That'll take the 24 volt input from your main power supply, spit it back out to the optional air pump that you can add to this laser, and then through Lightburn you can turn on or off air assist through layers feature. I love seeing that. There's been too many times with some lasers where I forget about the air and I gotta go turn it on, so I like having it controllable through Lightburn. Now with that, as I mentioned, it's an optional air pump. It does come set up with an integrated air assist cone and that hose that goes back to the side of the gantry, but you got to buy your own or supply your own air pump. Now it's great if you already have one or not, but they do offer one as an add-on. It would just be nice to see it included with this laser, as I really feel that air assist on anything over a 5 watt diode is just critical to be able to cut properly. So maybe they're just trying to keep the price down and let you add on the accessories you need, in which case that's nice. But I really would like to see the proper air assist pump included with the laser. So we've gone over the basic features and highlighted some of the build quality and such. So what I'm going to do next is I'm going to throw this into one of my existing enclosures. As I mentioned, they have an enclosure or a cover that is coming for this that has air exhaust and such, but it's not out yet. So in the meantime, I am going to be running this in one of my enclosures so we can do the testing, and hopefully down the road we'll be able to check out how it works with the actual integrated enclosure itself. So I'm going to get this set up and we will start with all the testing. All right, so I have it set up inside my custom enclosure here, so we'll be able to run these tests safely. And I was able to hook up an air pump to the output port, so we should have auto air. And we will be testing out some of the cutting features, engraving features and such. Now this laser does support both laser GRBL and Lightburn, and so we are going to be using Lightburn. I've already got that installed and I've set up the laser. It did detect perfectly automatically, so no problems there. Just made sure it was on the right COM port and then let it self-identify, and then just renamed it to the Atomstack A24 Pro. So no problems getting it set up with Lightburn as far as an existing setup out. Now, Atomstack is also coming out with their own software that they're writing for this. At the time of this video, it isn't available yet. So once that does become available, hopefully we'll get a chance to try that out and then revisit it with this laser as well. See how well that compares as maybe some starter software or for the long haul. But for now, we're going to be using Lightburn. So I'm going to go ahead and set up some test cuts and engraves, and then we'll check them out in a little bit. So I have done a few cut tests with this, and of course, as usual, I start out with a 3mm or 1/8 inch Baltic birch plywood. And hopefully, as you can see here, we did get a fairly good gradient on the cuts and also down on the engraving. So on the cut speed, we were running a full air, and on this initial test, I got up to 400 at 90 and 100, 400 millimeters a minute at 90 and 100% power. However, I was getting a little extra burning on there, and so I wanted to play around with the air assist and such. So the nice thing about this module is that the shroud around it does come off, and so that can sometimes trap some smoke in there if it's too close. And since I have it in my enclosure, it is safe to operate without that. So if you're running it without an enclosure, you're gonna probably wanna keep that on there and wear the glasses that come with it just to be sure. But since I have it in here, I'm pretty confident that it won't have any light escape. But so anyway, on the initial test, it was getting up to about 400 millimeters a minute. And then I ran it a couple more times. Like I say, I took the shroud off of it and played around with the cuts. Again, this time I was just using the cut file part of it. Here we squeaked out at 500 millimeters a minute, 100% power, getting all the way through. And then I ran it one more time just to be sure, and even squeaked in a 550 millimeters a minute at 100% power. But as you run these, you'll find that maybe some of them are kind of hit or miss up in those upper levels. So I generally like to back it off a bit. So I would probably run this specific material at about 450 millimeters a minute, 100% power, 90% power, in that range to kind of maximize my speed on cutting. This is actually performing pretty well. For a 20 to 24 watt laser, I would say it's kind of coming in just a little bit above the typical. Usually I'm running about 350 to 400 in other 20 watts. And so maybe there is something to their Gen 2 compressed beam technology. Maybe they are getting it down to 0.06 by 0.06, which would concentrate that cutting power in a smaller area. So after that, I went ahead and jumped into another material I've been starting to use, and this is the this is a 1/4 inch. Actually, it's 0.203 inches. It is a birch plywood from Home Depot, and I've done a whole video on testing this. This has been some pretty consistent material for me, so I don't get a lot of gaps or pockets in there, and so it generally cuts out pretty well. And you see here, even with this one, we're cutting at 450 millimeters a minute, 100% power. So again, I'd probably back that off to 400 and be able to run with a little more consistency on it. But very clean cuts, and the only thing I notice is that they're getting a little bit of extra burning on the bottom side or the start and the stop point of this. So possibly having to do with I'm using not the air pump that's meant for this one. I'm just using one that happens to work with that 12 volt out on the output side. So I would be very interested to see how these cut tests might improve with running the air pump that was designed for this laser. And then just for kicks, I wanted to grab some hardwood. This is a touch over 1/4 inch. This is a scrap piece of cherry, and cherry is a harder wood. So I ran the same test, and this was our results. We were able to cut through at 250 millimeters a minute, 100% power, but the rest of them just struggled through that. And then I didn't change my profile cut. That was up at, I think, 300. So it tried to get through. You can kind of see on the back, it tried to get through those full cuts, but didn't quite cut it on there. And so it's still possible, some thicker hardwood like this. But as you get into more dense woods, it's definitely going to need to slow down. And that's the point where you might need to be running multiple passes. And that's going to hopefully also cut back on some of this little, the vaporization that leaves there. The faster the laser's moving, the less charring and a little bit of less vaporization you get from the wood. So that's something that you want to play with as you get into these harder and thicker materials. Is this probably not going to be doable reliably and consistently in one pass? You're going to want to step that up to maybe 2 or 3 passes, running it at a slightly higher speed to get a clean and efficient cut. So going back to my original card here, you see at the bottom, I have a raster engrave We ran this at 15,000 millimeters a minute. Now I know they say that this laser will operate up at 36,000 millimeters a minute or 600 millimeters a second, but I mean, for a 365 millimeter width, you know, it's gonna then trying to cover that whole width in half a second. And I just don't feel that those are realistic speeds for anything other than like high speed moves and such. So I ran the test at 15,000 millimeters a minute, DPI 300, power, max power 100%, and you kind of see there, it's really, you get into this 80, 90, 100%, and they're looking very similar. You're losing the definition of the lines in between the marks. And so if I was to engrave using this mode, I would probably stick to maxing out at 70 to 75% power and to kind of get that full range, but not blow out your upper levels. You'll lose some definition at that point where they all kind of look the same. So I went ahead and did a couple of engraving tests. So this was the first one I did. This is just a little squirrel selfie kind of photo, and there's some friends in the background. And the photo itself that had kind of that shallow depth of field. So the ones in the background were a little slightly out of focus, and therefore they weren't going to be as sharp anyway. It came out okay. I think I could have played with this a little bit more, upped the contrast and played around with some of those settings. Tried to get it close and on the first guess. But it still came out all right. I'm still getting some detail. And so I ran this at 15,000 millimeters a minute. I had it maxed out at 70% power. I was using Jarvis mode, using a line interval of 0.06 millimeters or 423 DPI. And it took about 9 minutes, 45 seconds to engrave and cut out. So then I went ahead and took this photo from a site called laser-pics.com. This is the Imager website where you can, they have both paid and free photos, and you can set up your material and your DPI on the site and it will automatically process it for you. So I went ahead and did that and then turned Lightburn into pass-through mode, ran it with, set it up for 423 DPI, and of course this is 3.5 inches square. I ran it at 15,000 millimeters a minute, 75% power, and it took 14-20 minutes to complete and really came out quite well. You know, the detail in there is pretty good. The contrast is pretty good. So I was very happy with that. And again, that 423 DPI comes out to be a line interval of 0.06 millimeter. So I was really trying to see if that was too shallow and if we'd get overlapping lines or, you know, dark areas and banding. And I'm not seeing that here. So feeling pretty confident that they do have a tighter focus on their beams. So. All right, so I've tested a couple more materials, as you hopefully saw there, and started out with this slate tile. Now this is a tile I treated with satin polyurethane just to darken up the slate, and it gives a very nice white contrast with it. But I ran it at their recommended settings for rock, which is 25,000 millimeters a minute and 80% power, and it came out very well, and this only took 3 minutes to engrave. Now this was, of course, a vector image. It wasn't a raster. Those could take a bit longer to do, but for doing the types of things you're likely going to do with slate tile, and that is, you know, doing logos and text on them, pretty good and looking like a nice quality engrave. So then I went ahead and wanted to play with some acrylic. I started out trying to look at their settings and really came out, they had it like at 12,000 millimeters a minute and 80% power, and it was just blasting way too much through the acrylic. So I went ahead and just played around with some more of my own settings, ended up at about 13,000 millimeters a minute and about 55% power for the engrave, which has come out a lot better. And I will try to get a better close-up view of this for you. But then for the cut, I was using 375 millimeters a minute, 100% power and full air. And it gives it just kind of a nice matte edge. It's not too jaded or or crusty on either the top or bottom side. So kind of felt like those settings were pretty good for this. All right, so tried first the aluminum cards, the anodized one, and the blue I tried a couple times, front and back, and this is one of the natures of the blue light laser. It does have a little bit more difficulty interacting with the blue, so it wasn't burning through the anodization as cleanly as I'd like, so went ahead and just switched out to kind of this purplish pink one, and that came out very well. It blasted away the anodization, took it right down to the aluminum surface on bottom, and was able to do this at 15,000 millimeters a minute and about 40% power. So it took about just under 4 minutes to do the one card. So went ahead and tried our stainless steel little dog tags, and hopefully I'll be able to flash up a closer shot of this. It did interact with the stainless steel. Now this is more of a mirrored stainless steel, and that can have a harder time getting a clean engraving, but first ran my logo on one side, and you can kind of see it there, and then I went to just straight text to try to get something else. So there you have, if you have a dog or a cat named Fluffy, you could put this tag on there, and it worked out okay. But a lot of times they like to have more of a brushed stainless steel. So I have some thinner cards of stainless steel and ran it. And so I was able to get some markings on there, but it was deforming the card pretty easily. I tried upping the speed and dropping the power, but it wasn't working so great. So when you're working with thinner stainless steel, you're really gonna have to play around with some of your power and speed settings. Or what I would recommend doing is get yourself a can of Brilliance marking spray or Surmark. You put that coating on, then you can run it with no problem, and we'll see if we can get this to show up there for you, and I'll try to flash a close-up on there. But this is just a shark with a laser on its head. And this came out pretty well. There's decent contrast here as it is actually fusing that titanium dioxide in the spray onto here rather than trying to work with the coating and the stainless steel itself. So one of the things I want to take a look at is if we can measure the kerf of this laser, which will then kind of give us an idea, is the beam square? They're stating that it is a 0.06 by 0.06 millimeter beam. I don't necessarily have any tools to measure that actual beam width, and it doesn't get down to that focus point, but we can measure the kerf of some material to try to justify, is it at least a square beam? All right, so completed my test cuts, and I did it twice. I ran it once with the grain vertically and then once with it horizontally, and then went ahead, and these are all 25 millimeter squares that I programmed up to cut out, and did 4 of them to kind of get a good average in each orientation of the wood. And then took the measurements of both the squares themselves on the inside and then the cutouts on the outside to try to find the difference. And so just an example here in this first square, this one as a 25 millimeter square, it measured 24.85 millimeters wide in this direction, whereas the outline, the cutout was 25.41 millimeters. And then in the opposite, or in the other direction, the square was 24.61, whereas the cutout was 25.12. So I took all those numbers for both directions, added them up to find the average. And what I was finding was that my overall difference between the squares and the cutouts in the x-axis was 0.55 millimeter and the y-axis was 0.65. And so that was pretty consistent that they were all just a little bit taller than they were wider, which goes to show me that with the kerf difference that maybe the beam isn't quite square. Now there could be a little bit of calibration that needs to be done to make sure that it is traveling perfectly, 25 millimeters in each direction. There's a slight variance there. It's thankfully very small. I've seen them be much greater than that. So it's probably pretty close. And your kerf is going to differ in every type of material. So don't think that because I'm coming up with these numbers that the beam is focused way wider. There's extra burning and it removes more material than the beam width just as it goes through. So this isn't the actual beam width. It's just the kerf offset gives us an idea if that beam is wider in one direction or other. And it looks like it might be slightly wider vertically than it is horizontally. So the last test I want to run is we're going to try some thicker materials with this. A lot of people want to know, can it cut 3/4 inch or 1/2 inch material? And in some cases it can, but there's a lot of caveats to that. I'm going to be using some clear aspen. Now this is a very lightweight wood. It's very clear. It doesn't have a lot of varying grain. So it's going to have a really good chance to cut through. And it's also something that's generally available in most big box lumber stores and such. And so I'm going to get these set up in the laser. We'll see what we can do with them, and we'll look at the results after I'm done. So as you saw, we were able to get through the 1/2 inch clear aspen in 2 passes at 200 millimeters a minute, 100% power. Same thing with the 3/4 inch aspen with 200 millimeters a minute, 100% power, full air. And those look pretty clean. The edges, they are caramelized, but they're not like charcoal. Things that I would say is an acceptable cut. Now the speed on a larger object, it's gonna take a while, but it is doable. But I was hoping maybe with those successes we could get through some red oak, but it's just a little too dense, a little too hard for it to get all the way through. And so maybe 1/2 inch you'd have some success, but 3/4 inch oak is definitely pushing the abilities of this laser. The other thing to this is that I was setting the focus to if it was trying to focus more on the center of the item. So, if this is 3/4 inch material, you want to come down to 3/8, focus at the top of that. So if you've got a 3/8 piece of material, you can use your focus tool on that. Otherwise, you want to just at least estimate. You're trying to move that focus point down, so that kind of makes it a most efficient cut. All right, so I think that's where I'm going to wrap up the initial testing of this Atomstack A24 Pro machine, and hopefully this was informative for you. I did like a lot of things about this machine. I'm pleasantly surprised at its performance. It was definitely on the higher end as far as cutting my 3mm Baltic birch and some of that 1/4 inch plywood. And definitely the tests on that clear aspen shows that it does have some decent power behind it. They have a fairly square kerf, maybe not perfectly square, but it's not really far off to where it's going to create a huge problem for you on that. The one thing that you might notice is the working area is a little bit smaller. So if you're used to a larger laser, you may struggle with some of your same designs on there, but really you can easily fit a 12 by 12 piece of material in there. You can do a lot with that, and It'd be interesting down the road as some of the accessories come out for it to see how this might work as maybe a more portable shop type for you. If you're going to craft fairs and such, you definitely want to be able to keep your customers safe. And so having an enclosure that protects them from any of the light beams is going to be critical. And what I've seen of the preview of the cover that goes with this looks like it might do a nice job while still highlighting the fact that you're able to customize things on site. So as I mentioned, I'm going to wrap this one up here. I will have links down below to this laser as well as a few other things that I find useful in the shop or in testing with this. A lot of them will be affiliate links. They do provide a bit of a kickback to me at no additional cost to you. So I always appreciate you using them. If I helped influence you and encourage you for this, it's appreciated, but as always, no pressure. I'm just trying to do my best to give out some good information about various machines and what they might be able to do for you. I hope you found this video informative, and if you have any questions about this or anything else in my workshop, feel free to leave a comment down below. I do try to get back to those as quickly as I can. And if you liked this, hit that like button, and if you're new here, want to see more, consider hitting that subscribe button. It does help out a lot. Anyway, thanks again for checking this out. I hope to see you back here again, but in the meantime, I hope you can get out into your workshop and make something too. We'll see you next time.